Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. I hope you all are fine. I am Mrs. Amina Sadiq, working as subject specialist in mathematics at Divisional Public School and College Sahiwal. My dear students, today we are going to discuss about the theorems on proportions. This is exercise 3.4 from the unit 3. Before moving to our topic, let's discuss about proportion. A proportion is a statement which is expressed as an equivalence of two ratios. If the two ratios A ratio B and C ratio D are equal, then we can write it as A ratio B is equal to C ratio D, and the statement represents the proportionality of two ratios or the equivalence of two ratios. We can also explain this by converting the ratios into fractions, like we have two fractions 3/5 and 21/35. If their cross product is equal, then these two fractions are in proportion, or they are the equivalent fractions. Here is another example of two balls. If we can make this ball larger, it will be equal to this one, or if we make this ball smaller, this can be equal to this one. So, the relation between these two is equivalence relation, and this relation is called proportion, or we can say that the size of these two balls is in proportion. The contents for our today's lecture are the theorem of invertendo, the theorem of alternando, the theorem of componendo, the theorem of dividendo, and the theorem of componendo dividendo. Let's start with the theorem of invertendo. As the name suggests, in this theorem, the ratios are inverted. For this, we consider four numbers A, B, C, and D. If these two ratios, A ratio B and C ratio D, are equal, then their inverse ratios are also equal. So the theorem states, if A ratio B is in proportion to C ratio D, then B ratio A is also in proportion to D ratio C. We can also prove it by converting A ratio B into fraction A over B, and C ratio D can be written as C over D. By inverting these two fractions, we get B over A is equal to D over C, and when we write it in ratio, we get B ratio A is in proportion to D ratio C. Now we have the theorem of alternando. For this theorem, we again consider the four numbers A, B, C, and D. If their ratio A ratio B equals C ratio D, if we interchange the position of second and third terms, we get a new, that is, A ratio C is in proportion to B ratio D. So, the theorem of alternando states, if A ratio B is in proportion to C ratio D, then A ratio C is also in proportion to B ratio D. We can also prove it. We can convert the ratio A ratio B into A over B, and C ratio D can be written as C over D. Multiplying these two fractions by B over C, we get AB over BC is equal to BC over CD, or we can write it as A over C is equal to B over D, which when converted into proportion, we get A ratio C is in proportion to B ratio D. Now we have the theorem of componendo. Again we consider the four numbers A, B, C and D. If these numbers are in proportion, that is, if A ratio B is equal to C ratio D, then A plus B ratio B is in proportion to C plus D ratio D, or we can write it as A ratio A plus B is in proportion to C ratio C plus D. This can also be proved. We can write A ratio B as A over B equals C ratio D as C over D. Adding 1 on both sides, we get A plus B over B is equal to C plus D over D. Or we can write it as A plus B ratio B is in proportion to C plus D ratio D. Now we have the theorem of dividendo. For four numbers A, B, C and D, if A ratio B is equal to C ratio D, then A minus B ratio B is in proportion to C minus D ratio D, or we can write it as A ratio A minus B is in proportion to C ratio C minus D. This can also be proved. We can write A ratio B as A over B and C ratio D as C over D. Subtracting 1 on both sides, we get A minus B over B is equal to C minus D over D, which can be written in proportion as A minus B ratio B is proportional to C minus D ratio D. The next is the most important theorem, the theorem of componendo-dividendo. In this theorem, we have merged componendo and dividendo theorem. Again, we consider four numbers A, B, C and D. If A ratio B is in proportion to C ratio D, then A plus B, first term, is added to the second term. Ratio A minus B, first term, subtracted second term, is in proportion to C plus D, third term, plus fourth term. Ratio C minus D, third term minus fourth term, or we can write it as A minus B ratio A plus B, which is in proportion to C minus D ratio C plus D. We can observe that A plus B is the componendo part and A minus B is the dividendo part. Again, C plus D is the componendo part and C minus D is the dividendo part. We can change their positions, or we can invert them, or we can use invertendo theorem here to write it as A minus B ratio A plus B, which is in proportion to C minus D ratio C plus D. We are going to solve a number of questions by using the theorem of componendo and dividendo, so there is no need to prove it. And the first question from exercise 3.4, we are considering the first part. We have to prove that A ratio B is equal to C ratio D if this relation if we have 4A plus 5B over 4A minus 5B equal to 4C plus 5D over 4C minus 5D. To convert it into A ratio B equals C ratio D, we apply the componendo-dividendo theorem. For the convenience, I am calling this first term, this one as second term, this one as third term, and this one as fourth term. So first term plus second term divided by first term minus second term is equal to first term plus second term. third term plus fourth term divided by third term minus fourth term. After simplification, we get 8a over 10b is equal to 8c over 10d. Multiplying both sides by 10 over 8, we get a over b equals c over d, which can be written in the ratio as a ratio b is equal to c ratio d. For the sixth part, we have to prove that a ratio b is equal to c ratio d if a plus b plus c plus d over a plus b minus c minus d is equal to a minus b plus c minus d over a minus b minus c plus d. For the convenience, I am calling this as first term, this one as second term, this one as third term, and this one as fourth term. By applying componendo-dividendo theorem, we get first term plus second term over first term minus second term, third term plus fourth term, third term minus fourth term. After simplification, we get 2a plus 2b over 2c plus 2d, which is equal to 2a minus 2b over 2c minus 2d. My dear students, as you can observe that in this side we have a, b, c and d, all the four values, and in this right hand side we have also the four values a, b, c and d. To get two values on each side, we can interchange the places of these two terms, 2c plus 2d and 2a minus 2b. To interchange the places, we have to use the alternando theorem. After applying alternando theorem, we get 2a plus 2b over 2a minus 2b, which is equal to 2c plus 2d over 2c minus 2d. We have to prove that a ratio b is equal to c ratio d. Means in the left hand side we only need a over b. To convert this fraction into a over b, we applied componendo-dividendo theorem. By componendo-dividendo theorem, we get first term plus second term over first term minus second term, third term plus fourth term over third term minus fourth term. After simplification, we get 4a over 4b, which is equal to 4c over 4d, or we can write it as a over b is equal to c over d, which can also be written as a ratio b is equal to c ratio d. Now we have question number 2. Using theorem of componendo and dividendo, we have to find the value of x plus 2y over x minus 2y plus x plus 2z over x minus 2z if x is equal to 4yz over y plus z. Before starting the solution of this question, we have to understand the statement. We are given x is equal to 4yz over y plus z, and we have to find the value of this expression. Before starting our question, let's compare the coefficients of x, y and z in this given expression. Here the coefficient of x is 1. Here the coefficient of x is also 1, 1, 1 and 1. Y, z both have a coefficient 4. Here the coefficient of y is 2. Here minus 2. The coefficient of z is 2 and the coefficient of z here is -2. So we have to convert this 4 into its factors to give 2y and 2z. For this, we break 4 into its factors, that is 2y and 2z. This equation 1 can be converted into two cases. The first one is when x divided by 2y is equal to 2z over y plus z, and the second is when x over 2z is equal to 2y over y plus z. By applying componendo-dividendo theorem on both cases, we get two equations. X plus 2y over x minus 2y is equal to y plus 3z over z minus y, and x plus 2z over x minus 2z, which is equal to 3y plus z over y plus z. As we can observe that we get two equations having the two terms from this expression. So we add equation 2 and 3 to find the value of the given expression. We get x plus 2y over x minus 2y plus x plus 2z over x minus 2z is equal to y plus 3z over z minus y plus 3y plus z over y minus z. These denominators differ by sign. To match their signs or to make their signs similar, we take minus common from this expression. After taking minus common, we get minus y plus 3z over y minus z plus 3y plus z over y minus z. Now we have the same denominator, and we know that when two fractions have same denominator, the denominator is written once and the numerator is added or subtracted. So we get minus y minus 3z plus 3y plus z, which is equal to 2y minus 2z over y minus z. Taking 2 as a common factor and cancelling y minus z with y minus z, we get the value of the expression, that is 2, which is our required value. Now we are going to solve question number 2, part 6. The statement says, using the theorem of componendo and dividendo, we have to solve this expression x minus 2 the whole square. We have to solve this equation, that is x minus 2 the whole square minus x minus 4 the whole square over x minus 2 the whole square plus x minus 4 the whole square, which is equal to 12 over 13. By applying the componendo-dividendo theorem, we get first term plus second term over first term minus second term, which is equal to 12 plus 13 over 12 minus 13. After simplification, we get 2 times x minus 2 the whole square over minus 2 times x minus 4 the whole square, which is equal to 25 over minus 1. On simplification, we get x minus 2 the whole square over x minus 4 the whole square is equal to 25. Or we can write it as x minus 2 over x minus 4 the whole square. Taking square root on both sides, we get x minus 2 over x minus 4, which is equal to plus minus 5. Either x minus 2 over x minus 4 is equal to 5, or x minus 2 over x minus 4 is equal to minus 5. Solving these two equations for the values of x, we get x minus 2 is equal to 5x minus 20, or x minus 2 is equal to minus 5x plus 20. Solving it, we get two values of x. Either x is equal to 9 over 2 or x is equal to 11 over 13. If we check it, we get two solutions, 9/2 and 11/3. Now we have question number 2, part 7. The statement says, using the theorem of componendo dividendo, solve this equation. The square root of x square plus 2 plus the square root of x square minus 2 over the square root of x square plus 2 minus the square root of x square minus 2 is equal to 2. We all know that if we have a number, a whole number or an integer without a denominator, its denominator is 1 and it is understood. So applying the componendo dividendo theorem, we get first term plus second term, first term minus second term, which is equal to 2 plus 1 over 2 minus 1. On solving, we get 2 times square root of x square plus 2 over 2 times square root of x square minus 2 equal to 3. On solving, we get square root of x square plus 2 over square root of x square minus 2 is equal to 3. By using the property of square roots, we can write this fraction as a single square root, that is square root of x square plus 2 over x square minus 2, which is equal to 3. Squaring both sides, we get x square plus 2 over x square minus 2 equals to 9. Or we can write this equation as x square plus 2 is equal to 9 times x square minus 2. Simplifying this equation for the value of x, we get x square is equal to 5 over 2. We have to find the value of x, not x square. So we take the square root on both sides and get x is equal to plus minus square root of 5 over 2. When we check this for the solution, we get the solution set as plus minus square root of 5 over 2. My dear students, I hope you understand our today's lecture. Now it's time for your home task. You have to complete the remaining questions of exercise 3.4. Also solve the related examples. The topic we have discussed today has a great importance in our daily life. Like when an architect designs a house or a building, he needs to create a proportional relationship between the walls, the floor, the ceiling, the doors, windows, everything. Similarly, in the previous class, you have observed that the similar triangles have the proportional relationship of their sides between them. Similarly, you have also seen the proportional relationship in the theorems in class 9th. Moreover, an artist needs to create a proportional relationship or a proportional balancing in his paintings and artwork to create a masterpiece. And have you ever observed that Allah subhanahu wa ta'ala has created your face, your physique, your everything in proportion? So you can see proportion everywhere in your daily life. My dear students, I hope you understand our today's lecture and enjoyed the topic. Stay safe, stay calm, stay happy, and stay at home. Thank you and Allah Hafiz.